Hi students, small request Nana. Without subscribing my channel, you are watching my videos students. Please subscribe my channel. Uh, please support me Nana. Then I can do more videos students. Please Nana. Please. Thank you students. In today's session, I'm going to discuss about the VBT Nana. Valence bond theory, 12th class topic. Lesson name coordination compound students. Okay Nama. Now here complex. Here I gave the tricks Nana. First to calculate the oxidation number of the central metal atom. Second trick is you have to identify the ligand. It is whether it is strong field ligand or weak field ligand. Okay now example students, strong field ligand NH3Cn minus F minus Cl minus. These are the weak field ligands. If it is strong field ligand students, 3D electrons will get paired. If it is weak field ligand, 3D electrons do not pair up Nana. These two tricks you have to remember students. Then you can easily calculate the geometry hybridization that all students. Okay Nama. So the complex is NiCl4 2 minus NiCl4 2 minus. So this complex we have to find the geometry, okay, hybridization, magnetic nature, that all you have to find out. Okay, so first trick number 1, calculate oxidation number of the central metal atom. So first I am going to calculate the oxidation number of the central metal atom students. Nickel I am going to calculate. Is the central metal atom, it is the ligand. So chloride is this weak ligand kada. It is weak ligand, weak field ligand, chloride example. So it is a weak ligand and it is a central metal atom. So ligand is nothing but it is ready to donate the pair of electrons to the central metal atom. Metal atom is always ready to lose electrons. Because of loss of electrons, it becomes electron deficient. So that's why it is ready to accept the electrons from the ligand students. Okay, now I'm going to calculate the oxidation number of the central metal atom. So I'm taking as X Nana. X plus 4 chlorines are there. Chlorine oxidation state is -1 equal to -2. Charge -2 there. Nickel is, I'm going to calculate, I'm taking as X. 4 chlorines. Chlorine oxidation number is -1 equal to -2. Then you will get X minus 4 equal to -2. X is equal to +2 students. This is the oxidation number of nickel Nana. Nickel oxidation number +2. Right. Now first I'm going to write the atomic number of nickel. See here, nickel atomic number: scandium, titanium, iridium, chromium, manganese, iron, cobalt, nickel. 28 atomic number argon, 4s2, 3d atom. Electronic configuration: argon 4s2 till here 20 electrons over. This is 28 electron Nana. So total 28 electrons satisfied. Okay, now how many electrons lost? 2 electrons lost. So that's why by loss of 2 electrons, this electronic configuration becomes here 2 electrons from where it is losing? From 4th shell, valence shell. 3d8 as it is will be there. 3d8, 4s0 students. Now I am writing the orbital structure students. Ni plus 2. See here 3d8 and 4s0. Okay, see here I am writing Nana. Ni plus 2, 3d8 to 4s0. Right. So in 3D total how many orbitals students? 5 orbitals. In 4s 1 orbital. So how many electrons in 3D? 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. 4s is 0 now. Completely it is vacant students. Okay. Now you have to identify the ligand is weak or strong ligand. Yes, chloride is a weak field ligand. So that's why 3D electrons do not pair up. 3D electrons as it is will be there. Okay, so this one as it is I am writing again Ni plus 2 here. Ni plus 2, 3D as it is I am writing total 5 orbitals and 4s completely vacant. Total here 8 electrons are there. 1, 2, 3, 4, 5, 6, 7, 8. Are you understanding? Here if it is strong ligand students, what will happen? 3D electrons will get paired. But here it is weak ligand now. So this unpaired electrons as it is will be there. They will not get paired. Okay. Understanding Nana forest as it is. Now you have to see how many ligands are there. 4 ligands are there. So that's why 4 ligands donating the 4 pairs of electrons to the central metal atom. That's a nickel. Nickel requires how many vacant orbitals? 4 vacant orbitals required, because here 4 chlorines are there. That's why here nickel also 4 vacant orbitals required, because 4 pairs of electrons come into the nickel, students. Are you clear? So that's why nickel 4 vacant orbitals required. Already here 1 is there, vacant orbital, still 3 required. That's why I am taking from 4p, students. From 4p, it is the fourth shell is the valence shell. We can take 4p. It is completely vacant. Total how many? How many orbitals, students? 1, 2, 3, 4. So total we are having total 4 vacant orbitals. Clear? 4 vacant orbitals. Now these orbitals are undergoing hybridization, students. See here, 1 s orbitalu, 1, 2, 3, 3 p orbitals, correct? 1 s orbitalu, 1, 2, 3, 3 p orbitals. Are you understanding? 1 s, 3 p orbitals undergoing hybridization, students. Hybridization produces, students, hybridized orbitals. How many? 1 plus 3, 4. S1, P how many? 3. P3. sp3 hybrid orbitals. Hybrid orbitals are formed. Okay, now 4 sp3 hybridized orbitals are formed. Now these 4 sp3 hybridized orbitals I am writing separately, students. See here, Ni plus 2. This is 3D. This 4 I am writing in one place only, joining these 4 orbitals. Okay, this is which one, students? sp3 hybrid orbitals. Okay, 3D. How many electrons there in 3D? Total 8 electrons there. That as it is I am writing 3, 4, 5, 6, 7, 8. Okay, 8 electrons. sp3 hybridized orbitals are formed. Now these sp3 hybrid orbitals are undergoing overlapping, students. Overlapping with the which, students? Overlapping with the filled orbitals of 4 chloride, students. Filled orbitals of filled orbitals of 4 ligands. Ligands which one, students? Cl minus. 4 ligands Cl minus. Are you clear? So these orbitals are undergoing, these are which orbitals? Nickel orbitals, hybridized orbitals. These orbitals, nickel orbitals, are undergoing overlapping with the 4 filled orbitals of chloride. Now these 4 chlorides, so donating the 4 pairs to the central metal atom. Okay, now see, students, here 4 vacant boxes are there. Here 4 vacant boxes will become paired because of undergoing overlapping. Now see here, this electronic configuration I am writing like this. 3D. Next, these 4 boxes also will get paired. Okay, these are electrons of ligands. These hybrid orbitals are filled with which electrons? Ligands electrons, because 4 ligands donating 4 pairs. Okay, 4 pairs. So 1, 2, 3, 4. 4 pairs. These 8 electrons you write as it is. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now conclusions, students. What are the conclusions? See here. Hybridization. Tell me, students, what is the hybridization here? sp3 hybridization. So sp3. What is the geometry, students? sp3 hybridization there means geometry is tetrahedral shape. Tetrahedral shape. This shape, how to identify, madam? sp3 tetrahedral means this table you have to practice, students, then you can easily write. Okay, sp3 hybridization there means tetrahedral. dsp2 square planar. This is trigonal bipyramidal. These two are octahedral. Okay. Now see here. So it is tetrahedral geometry. And coming to the magnetic behavior, students, magnetic property. Magnetic property. Tell me, Nana, magnetic property. It is diamagnetic or paramagnetic. So when you are writing magnetic property, you have to see only 3D electrons. These are paired, unpaired. Only this 3D only you have to see. See here, paired, paired, paired. But here unpaired electrons there. Now unpaired electrons there means paramagnetic. All paired means diamagnetic. Clear? So it is unpaired electrons is having so that's it is which one? Paramagnetic in nature. And next, completed students, this is about the VBT Nana of this complex. Clear? These are the conclusions. This match you have to write, Nana. Okay, it is very important question in the board exam. Students, direct questions also you will get for the competitive exam students. I hope you like this video. If you like this video, please like, share, comment and subscribe my channel, students. Thank you, students.